Okay, so in this lesson, we're going to look at transformations of the square root of x, so this radical function, square root of x. So f of x, let's go ahead and write this as f of x. Remember, y is the same thing as f of x, just written in function notation. So f of x, let's say, is equal to square root of x. And so this will be our parent function, and from this parent function, we can graph other functions through these transformations. So remember when we did the absolute value function, the parent function, we use these 5 points, and then you move those 5 points, whether you did a vertical translation or a horizontal translation or reflection. Okay, so these 5 points were used. The same thing for we did the quadratic function. So when we did the quadratic function, we used these 5 points. All right, so for for the square root function, we're going to use these points. Now, keep in mind that when we graphed, when we used, or when we graphed the parent function here for the absolute value of x, I want you to notice that the domain here was all real numbers. Okay, so every real number of x is going to be on the graph. So if x is 100.7, if x is 100.7, I'm going to get a y value. If x is negative 1 million, I am going to get a y value. So the domain here is all real numbers. The same thing when we talked about the quadratic function. So when you looked at the graph of the quadratic function, this right here, f of x equal x squared, the domain was also all real numbers. Every point, every real number of x, you're going to get a y value. Every real number of x, you're going to get a y value. If x is 8, I get a y value. If x is 110, I get a y value. If x is negative 1 billion, I will get a y value. So the domain's all real numbers for both the parent function x squared and absolute value of x. That is not true for the square root function. Because remember, you can only take the square root of a positive number or 0. You can only take the square root. You can only take the square root of any positive real number or 0. Okay? You cannot take the square root of a negative number. We saw that in the previous course, and we saw that at the first week of school. For example, the square root of 9, which equals 3, is a real number. But the square root of negative 1 is not a real number. Remember, that's the imaginary unit. So that's not a real number. And when we're graphing real numbers. So when you're talking about the square root function, your domain is restricted. So basically what you're asking yourself is, you see this radicand? Remember, your radicand must be positive or 0. Positive or 0 means this. Positive means bigger than 0, or 0 means equal to 0. So basically what you're going to do is you're going to take your radicand, which in this case is just x, and you're going to say, I can only use values of x that are greater than or equal to 0. That's all I can use. I can't use a negative number. I saw that. For when the radicand is x, for this parent function, I can only use values of x that are positive or 0. Okay? So when I do a t-table, when I look at those points that I need to use every time I do a translation, a transformation, I got to use 0. So if x is 0, I get y equals the square root of 0, which is 0. Let's go ahead and use 1. Since 1's a perfect square, let's use it. I get y equals the square root of 1, which is a nice number, because remember we said let's use a perfect square, and 1 is a perfect square, so the square root of 1 is 1. Let's use another perfect square, so let's say 4. Y equals the square root of 4, which is 2. And let me go ahead and get a grid paper just to kind of show you what's happening at this point. So when I find okay, so when I graph those 3 points, let me just kind of show you what's happening. All right, so when I graph those 3 points, I have 0, 0, I have 1, 1, I have 4, 2, okay? And if I do, let's say, this 3, all right, I'm going to have to use a calculator. And um, obviously I don't have the calculator with me. So let's see, where is this calculator? All right, so let's say the square root of 3. So the square root of 3 is 1.73. So let's say 1.7. So when x is 3, y is 1.7. So let's say that's about here. When x is 6, let's say 6, I get 6 square root. So that's about 2.5. So let's say that's about, oops, I said 2.5. So let's say that's about here. When x is 2, x is 2, I get 1.4. So let's say that's about here. All right, so what's happening is that you're getting this graph right here. That's what you're getting. So you're getting a graph that looks like this. And if I want to show you something, if I were to kind of rotate it, you get part of a parabola. So you get part of a parabola. So always think about that. It's got to look, when you graph it, when you graph this, and obviously I didn't do a very good job with it, but when you graph it and you rotate it, it's going to look like part of a parabola. So it's going to have that shape of a parabola, or part of a parabola, the one half of it. Okay? All right, so that's what the square root function looks like. Now, as far as how many points you're going to need, I'm using irrational numbers for y is you have to estimate this. So for right now, let's just use these three numbers 0, 0, 1, 1, 4, 2, and knowing that when you graph it, just make it look like you're graphing a parabola. Okay. All right. So let's look at this one. So this is going to be number 1. So use the graph of f of x, which equals the square root of x, to obtain the graph of g of x, which equals the square root of x minus 2, let's say. Okay? All right. So basically what I want to do is I want to take this parent function, and I want to go ahead and translate it. And remember from a previous lesson, remember when we did this, when we translated this 3 units, remember this meant 3 units down. So the same idea, you're still going 3 units down. When it's in the inside, that's a horizontal shift. Okay, so you gotta remember this. If it's on the outside, it's a vertical shift. When it's on the inside, it's a horizontal shift. Remember this right here means a reflection. Then here you have a vertical shift, a horizontal shift, and the reflection. Now keep in mind though that when you do a horizontal shift, remember it's counterintuitive. So even though this says x plus 4, you're actually going to shift it 4 units to the left. And it's for x minus 4, you would shift it 4 units to the right. Okay, so all these are prerequisites for what we're about to do. So when you graph this, you're, and let's go ahead and graph it on this one. Actually, let's do this one. So first of all, I'm going to go ahead and graph the parent function. So this is my parent function. So this right here is f of x equal the square root of x. So let's go ahead and graph that. And let's see. So I'm going to use 0, 0, 1, 1, and 4, 2. All right. And so then we're going to graph it like this. Okay. All right. So let's see what happens when I shift this thing down 2 units. So when I shift it down 2 units, what's happening is this. This is 1, and this is 2. So eventually we get a graph that looks like this. So in your mind, and it helps if you have some kind of transparency or something, tracing paper or something, just to kind of give you an idea what's going on. But remember this right here, if the number's on the outside, that means that's a vertical translation. And it's a -2 means that you're going to take the parent function and you're going to translate it down 2 units. So you're going to go down 2 units. And so what's happening is this. So when I actually do translate this down 2 units like this, I'm going to get this. Okay? And just kind of like what happened before, basically every point in that graph is going to go down 2 units. You're shifting it down 2 units. So 0, 0 becomes 0, -2, 1, 2. Now remember what you're graphing is this now. So keep in mind what you're graphing. What you're graphing is g of x. Go ahead and write it here. So you're graphing g of x equal the square root of x minus 2. So if the number's on the outside, if c is on the outside, if the constant's on the outside, you're gonna do a vertical translation. So you bring this down 2 units. 1, 2. Bring this down. Let's do the 4, 2. Bring this down 2 units. You get 1, 2. And so when you graph it, when you graph this, you're going to get this. All right, just like a parabola. So make it kind of look like part of a parabola. Okay, like 1/2 of a parabola. And so there's your graph. And so notice that it looks like the parent function has been translated down 2 units. So you see 2 units, 2 units. All these distances are the same. All these vertical distances are the same. They're 2 units. Okay, make sure you see this. All these vertical distances are the same. They're all 2 units. So make them look like that. Make them look like these distances are the same. Okay, so so this is what it would look like on a worksheet. So you'd have the parent function, and that was only one translation you had to do. It had to be a vertical shift. So you do it, and then you say this is g of x. So g of x equals the square root of x minus 2. Okay, so that was that one. All right, let's look at, so this is number 1. Let's look at number 2. So let's suppose number 2 is this. So number 2, let's suppose that it says use the graph of f of x, which equals square root of x, so that's your parent function, and you want to use this to obtain the graph of g of x, which equals the square root of x minus, let's say 2, x minus 2. All right, so listen carefully to this. So remember, basically what's going to happen is that I'm going to graph this parent function. Remember, the way they want you to do this is to graph the parent function and then use the idea of translation in order to do this. Okay? So what this means is that we're going to take the square root of x, take the graph of the square root of x, and shift it horizontally. I mean, that's a horizontal shift, horizontally to the, and remember, it's counterintuitive, so don't say 2 to the left, it's actually 2 to the right. So 2 units horizontally, 2 units to the right. So that's what it means. So inside is a horizontal shift. So again, so basically, you would look like this. So you're going to take your parent function. Right, so it looks like this. There's your parent function, and you're going to shift it 2 units to the right. So look, 1, 2. Okay, so that's what it would look like. So so your parent function would have been shifted 2 units this way, 2 units to the right. Okay, so let's see how this looks. So basically, you're going to graph the parent function. So you can say 0, 0, 1, 1, 4, 2. Just do this. Just graph it like this. Okay, make it look like part of a parabola. And now you're going to take each point and you're going to shift it 2 units to the right. You'll take each point, and remember this is f of x equals square root of x. You're going to take each point and you're going to shift it 2 units to the right. So 1, 2, 1, 2, 1, 2. And so when you graph it, it will look like this. So this is a graph of g of x, which equals the square root of x minus 2. Okay, so make it look like, always make sure you make it look like you're shifting 2 units to the right. 2 units, 2 units, and you're done. Just connect the dots. Okay? Now you see how the vertical shift, you can actually see how those distances are the same. That's not true. With the horizontal shift, the distances are not necessarily going to be the same. Okay, 2 units. You see how what I'm talking about here is this. Uh, it kind of looks at some point where see how it kind of looks like here where that space is where this space is smaller than this space right here. Okay, that's because you're looking at vertical distances. So be careful. You're looking at horizontal distances. So vertical distances is easy to see. You can actually see that the vertical distances are the same. Okay. The here you're looking at horizontal distances. So the horizontal distances are the same. It's just that the vertical distance idea is throwing you off. So it kind of looks like you did something wrong. You didn't do anything wrong. Just look at these horizontal distances. That's what this is. This is a shift horizontally. So is that 2 units? Yes. Is that 2 units? Yes. Is that 2 units? Yes. And we do this one, that would be 2 units also. Okay? So the horizontal distances are the same. It's just that vertical distances are not identical here. Okay? All right. So notice these distances are not identical, but since it didn't involve any vertical shift at all, it just involved a horizontal shift. So don't let this throw you off. It's still correct because you're looking at horizontal distance. Horizontal distances are the same. All right, number 3. Let's suppose we had this. Number 3. All right, use the graph of f of x, which equals the square root of x, to obtain the graph of g of x, which equals, now let's do a reflection. Let's do a reflection. So let's say the reflection is the square root of x. All right. Let's do the square root of x plus 3. Let's do that. So let's do this one. So here, I want you to notice that in this one, there was one transformation. It was just a translation. Here, we had one transformation. It was a translation. Here, there are two. There's a horizontal shift and a reflection. Okay? Here, there was just a horizontal shift. Here, there was just a vertical shift. Here, we have two things. All right. So in graph, you're going to have 3 different graphs on here. You have the parent function. Then you're going to have the horizontal shift, and then you're going to have the reflection. Okay. All right. So let's kind of talk about what this is. So you're going to shift. You're going to shift horizontally. You're going to shift the square root of x horizontally to the. And remember, counterintuitive. So don't say 3 units. I'm going to do right as shift horizontally 3 units. Don't say 3 units to the right. It's actually to the left. So 3 units to the left, and then reflect, because remember this negative out here is a reflection about the um, x-axis. So then reflect about the x-axis. So when you graph this, here's what we're going to get. Okay, so you're first of all going, just look and see what this looks like, and then we'll graph it. So you have the parent function. So remember 0, 0, 1, 1, 4, 2. So you have this. Oops, it's not scaled right. So let me go ahead and redo this with that particular scaling. All right, so this scaling looks different than the other one. So this is 0, 0, 1, 1, 4, 2. So it looks something like this. Okay, and so it says that we're going to shift it. I'm going to shift it 3 units to the left. 3 units to the left. So it's going to eventually look like this. So you're going to move. You're going to move this 3 units to the left. 1, 2, 3. Okay. And then you're going to reflect this. You're going to reflect it about the x-axis. So when you do that, this is what the graph's going to look like. Okay, so the graph I'm interested in, the final graph, will look like this. It'll be a reflection about the x-axis. All right, so remember this is what we did. So we took the parent function, we shifted it 3 units to the left, and then we reflected it. So you reflect it, you're going to get this. Okay. All right. So let's actually draw this. So the first thing we're going to do is I'm going to draw the parent function. So 0, 0, 1, 1, 4, 2, or something like this. All right. So then I am going to shift it 3 units to the left. 3 units to the left. To this point, move 3 units to the left. 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3, and then connect them. And so you get something that looks like this. Okay? Just do the best you can with this. Don't make it look like a segment. It's actually curved. Just remember, it's part of a parabola. So if you turn it sideways, it's supposed to look like half of a parabola. All right. And then what you're going to do is you're going to do the reflection. Now remember, when you do the reflection, for instance, if this, see this y coordinate, which is 2, when you reflect it about the x-axis, it becomes -2. So the x-coordinate will stay the same. It's just that your y-coordinate is going to, your point's going to be reflected, so your y-coordinate will be the opposite of what this one is. So you just reflect the point about the x-axis. So 2 units, 2 units down. So this is, all right, so, okay, then this one here. So then this is, the y value here is 1, go 1 down. About the x-axis, and then this stays the same. And so now you just get this. Now do the best you can. Kind of do this, draw it this way to make it look like part of a parabola. So I'm kind of using this idea of symmetry, because it really is half a parabola. All right, and so you get that. So the red graph is the one I'm interested in. So the red graph is g of x is equal the opposite of the square root of x plus 3. And that's what you just graphed. Okay? Alright, so remember this right here was the square root of x. This was the square root of x. And then here you shifted it 3 units to the left, and then you did the reflection. And so that's your final graph. Alright, let's look at this. Suppose number 4, you were asked to do this one. Number 4. Alright, suppose in number 4, it says use the graph of f of x, which equals the square root of x, to obtain the graph of g of x, which equals, all right, let's do this. Let's do a reflection. Let's do a horizontal shift. And let's do a vertical shift. Okay, all right, let's do that. Okay. So remember the order. You got to do it in a certain order. Okay, so the vertical shift is always done last. Always do the vertical shift last. And in here, we're not dealing with stretching or shrinking. So there's only going to be 3 transformations that you have to do. But always do the vertical shift last. So you can do a horizontal shift first. So let's talk about that. So we're gonna take the square root of x and then shift it horizontally 3 units to the, and then you got to determine which side. Remember, it's counterintuitive, so don't say 3 units to the left because this is negative. You got to do the counterintuitive part. So it's actually 3 units to the right. So 3 units to the right. Okay. Then we're going to do the reflection. So you can say then reflect about the x-axis. Reflect about the x-axis. And then we're going to do the vertical shift. So then we're going to go 6 units. Since it's positive, we can go 6 units up. Then shift vertically. Then shift vertically up 6 units. Okay? Alright, so let's see what this graph looks like. Alright, so we graph it. It's very simple. It's not that difficult. So remember, you're going to graph the, in your mind, if you want to kind of look at what it looks like in terms of transparency. Let's see if this is the one I need. No, that's not the one. This is the one I need. Alright, so, so remember, this is the parent function. So this says I've got to shift it horizontally to the right 3 units. So 1, 2, 3. And then I'm going to reflect it. Okay, so I'm going to reflect this, like this. And then I'm going to move it up 3 units. So what? Just watch this right here. 1, 2, 3. So that's what my final graph should look like. So in your mind, and it helps if you have a transparency or something, but you may not have access to that. But that's what you do. You just shift it up 3 units, and that will be your oops. It was supposed to be 6 units. I'm sorry, 6 units. 3, 4, 5, 6, and then you shift it up 6 units. See the 6 right here? That's where it needs to be. Okay. All right. So let's actually do this. So on a worksheet, this is what you would show me. You would say, all right, let me go ahead and graph the parent function. So 0, 0, 1, 1, 4, 2. Once I get this graph. Then I am going to shift it to the right 3 units, because remember that's what this says. You do the horizontal shift next. So since it's x plus 3, I'm sorry, x minus 3, it actually means go to the right 3 units. Right, so when I shift it to the right 3 units, move every point to the right. 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, you get something that looks like this. Okay, just do the best you can with it. All right, and then remember, it's not that bad to draw. Just think of you don't actually do it, but just think of you drawing the other part of this problem, make it look symmetrical about this axis right here. Same thing here. Okay. All right, so then I am going to reflect the green graph now. So remember, the blue graph was the parent function. The blue graph was the parent function, square root of x. The green graph was the shifting to the right 3 units. So that's that. And then the red graph, I'm going to use a different color. Let me use that blue ink right here. And, all right, so then the blue ink pen then will be where we do the reflection. So we see where this y value is 1. When I reflect this point about the y-axis, becomes this point here, where the y value is -1. This y value is 2. Reflect that point about the x-axis. I get this point here, and then this point 3, 0 stays 3, 0. And so I get this right here. Okay, do the best you can with this. Make it look like a parabola. And it looks okay. All right, so this would be negative square root of x minus 3. So that's the graph I just did. I did this. Now I got to remember what I'm graphing, though. What I just want to graph is not this. I'm getting there. You see where this looks like this? The only thing I'm missing is that plus 6. So what I'm going to do now is I'm going to take the graph that's in blue ink, and I'm going to shift every point up 6 units. And that's going to be the red graph. All right, so here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then just make sure I did this right. 1, 2, 3, 4, 5, 6. Okay. So then just connect those, just kind of like you're drawing a parabola. So if you need to kind of rotate it a little to help you draw it, that's fine. Go ahead and do that. Just make it look like a parabola. Okay. It looks something like this. And so there's your graph. So the red graph is, don't forget the arrow, so the red graph is g of x equals the opposite of square root of x minus 3 and then plus 6. All right, so that's how you're going to do the transformation. So notice that in the number 4, you had a horizontal transformation, you had a reflection, and you had a vertical shift. So there are 4. So that's 3 things here, but you have to graph the parent function. There are 4 graphs you have to show. So notice there are 4 graphs here: the parent function, the horizontal shift, which is the green one, the reflection, which is the blue ink, and then the vertical shift, which is your final graph. Okay, which is the red graph. All right, so that should take care of the information on transformation. So that should give you enough information to work on these.